Ever wondered why we have day and night? It's all because of Earth's rotation. Imagine a spinning top. That's Earth, spinning on an imaginary line called its axis. This rotation is a ceaseless dance that completes a full turn approximately every 24 hours. That's why we see the sun rise in the east and set in the west, creating the cycle of day and night that we all live by. But, it's not just a simple spin. Earth's rotation is a complex mechanism influenced by various factors. Gravitational interactions with our moon and the sun play a significant role, pulling and tugging at our planet. Even geological processes like tectonic movements deep beneath our feet can have an impact. So the spinning Earth is fundamental to life as we know it. Without it, our world would be a very different place indeed. Stay tuned as we delve into a hypothetical scenario where Earth's rotation comes to a sudden halt. Now imagine a world where Earth's rotation suddenly halts. A situation that's fascinating in its terrifying implications. In this hypothetical scenario, our planet's spin slows down significantly, or even comes to an abrupt stop. But what could possibly cause such a dramatic shift in Earth's motion? Consider for a moment gravitational anomalies. These could be triggered by unforeseen cosmic events, disrupting the delicate gravitational balance between Earth and other celestial bodies like the Sun and the Moon. Alternatively, an asteroid impact of colossal magnitude could potentially alter the planet's rotational speed, and let's not rule out the possibility of human intervention. Unprecedented technological advancements or disastrous mishaps could theoretically play a role in such a scenario. Regardless of the cause, the effects would be truly monumental. From the redistribution of Earth's mass to the cessation of tectonic activities, the implications are staggering. A stopped or slowed Earth would dramatically alter life as we know it. The Earth's shape and gravitational field would be the first to feel the effects. The planet's rotation causes it to bulge at the equator, but without this centrifugal force, Earth would gradually become more spherical. This redistribution of mass would profoundly change the planet's gravitational field, affecting everything from the flight of birds to the orbit of satellites. But the cessation of rotation wouldn't just reshape our planet, it would also bring the tectonic plates to a standstill. These massive slabs of Earth's crust, currently driven by the planet's rotation, would cease their movement. This could potentially trigger unprecedented seismic activity, causing earthquakes and volcanic eruptions on a scale we've never seen before. The landscapes we know and love could be dramatically altered, mountains could crumble, and new land could rise from the sea. These dramatic shifts in Earth's geology would set the stage for even more profound changes. The geological upheavals would be just the beginning. Without rotation, Earth's environment would undergo extreme changes. Imagine a world split in two, one half in perpetual daylight, the other in endless night. This would create extreme temperature differentials. The sun-baked side could reach temperatures hot enough to boil our oceans, while the dark side might become as cold as the depths of space. But that's not all. Earth's rotation drives our atmospheric circulation. Without it, our weather would go haywire. The hot side would heat the air, causing it to rise and create a vacuum that pulls in cold air from the dark side, potentially resulting in violent winds and storms. The disruption to our atmosphere could also spawn new and more severe weather phenomena, like supercharged hurricanes or devastatingly long-lasting blizzards. In essence, without Earth's steady spin, we'd be at the mercy of a wildly unpredictable and potentially hostile climate. Earth's climate and weather patterns would be in turmoil. The halted rotation would force all life on Earth to adapt or perish. Picture this. Our flora and fauna dealing with a world of extremes, one side in eternal daylight, the other in perpetual night. Plants that rely on photosynthesis would struggle in the constant dark, while animals adapted to specific light conditions would find their survival strategies rendered obsolete. Extinction could loom for those unable to adapt. Yet, nature is tenacious. Some species might evolve rapidly, developing traits to withstand extreme temperatures or altered light conditions. And what about migration? Imagine entire species moving en masse toward the twilight zone, a narrow band of Earth where conditions might be more favorable. This twilight zone could become a refuge, a Noah's Ark for biodiversity in a world turned upside down. Life as we know it could change dramatically, with new ecosystems emerging from this survival of the fittest. Life on Earth would face an unprecedented challenge. Our societies too would face significant challenges. With Earth's rotation grinding to a halt, the infrastructures we've built, predicated on a rotating Earth, would be thrown into disarray. Imagine vast power grid failures, as solar and wind energy systems struggle to adapt to the new extreme conditions. Communication systems too would face disruptions as satellite networks designed for a spinning globe scramble to recalibrate. But it's not just about the immediate challenges we'd face. It's about the long-term adaptations we'd need to make to survive. Our homes, cities and towns, for instance, are designed for the climates we're accustomed to. How do we maintain habitability when one side of the Earth is perpetually baked in sunlight and the other plunged into unending darkness? Enter the realm of human innovation. We've shown time and again that we can rise to the occasion when faced with adversity, and this would be no different. The need for new technologies would skyrocket, and we'd see a surge in scientific research and development like never before. For instance, artificial lighting systems would become crucial for the side of the planet stuck in perpetual night. We might develop advanced solar capture technology on the sunny side, storing and transferring energy to the darker regions. We'd also need to create climate-controlled habitats, perhaps underground or in enclosed structures, where we could regulate temperature and light levels, ensuring our survival in these harsh new conditions. Agriculture, too, would need a complete overhaul. We'd likely see a shift towards indoor farming, using hydroponics and aeroponics, with LED lights mimicking the sun's spectrum to grow our food. And while these innovations sound like science fiction, they're not entirely out of reach. We've already seen glimpses of these technologies today, from vertical farms in urban jungles to experimental moon bases. The hypothetical scenario of Earth's early stop rotation is a stark reminder of our planet's delicate balance and our place within it. It underscores our vulnerability, yes, but also highlights our resilience, adaptability and capacity for innovation. Because when push comes to shove, human ingenuity would be put to the ultimate test. The loss of the day-night cycle would affect more than just our sleep schedules. Imagine a world without the familiar rhythm of day and night, sunrise and sunset. This would not only disrupt our daily routines, but could also cause significant cultural shifts. Traditions tied to solar and lunar cycles, like festivals and ceremonies, would become meaningless. Our concept of time, built around the 24-hour day, would need redefining, potentially reshaping our societal structures and norms. Extended periods of daylight or darkness wouldn't just have physical implications, but psychological ones too. Continuous exposure to sunlight or perpetual darkness could lead to a range of mental health issues. For instance, people may struggle with insomnia, depression, or heightened anxiety. Light therapy, currently used to treat seasonal affective disorder, might become a widespread necessity. Our societies and mental health could undergo profound changes. This hypothetical scenario underscores the delicate balance that sustains life as we know it. Over time, the halted rotation would reshape Earth and life on it. We'd witness an evolutionary marathon where the only rule is adapt or perish. Species from the smallest microbes to the largest mammals would face the test of survival under extreme conditions. Some would thrive while others would falter, leading to a significant shift in Earth's biodiversity. The twilight zone, the narrow band of habitable space between the scorching heat of perpetual day and the frigid cold of eternal night, would likely become a hotbed for life. Here, new species may emerge, adapted to the unique conditions, while others could migrate from the inhospitable regions, creating a new ecological balance. But it's not just the living inhabitants of Earth that would face a dramatic transformation. The very face of the planet itself would change. Without the rotational forces that drive geological processes, the landscapes we know and love would gradually morph into something unrecognizable. Imagine vast plains where mountains once stood, their mighty peaks worn down by the relentless forces of weathering and erosion, unchecked by the movement of tectonic plates. Or envision new landforms emerging, sculpted by the extreme climatic conditions of a non-rotating Earth. And what of our oceans? Without the moderating influence of rotation, they could migrate towards the poles, forming two giant polar oceans, separated by a supercontinent that spans the equator. This would create a radical new world map, turning familiar coastlines into distant memories. As for the atmosphere, the halted rotation could disrupt the balance of gases, potentially altering the composition and density of the air we breathe. This could lead to changes in the color of the sky, the intensity of solar radiation reaching the surface, and even the sound of the wind. In essence, a stopped Earth would be a vastly different world. It's a scenario that underscores the delicate balance that sustains life on our planet and the profound interconnectedness of all Earth's systems. It's a reminder that even the seemingly constant can change, and that our survival depends on our ability to adapt to the unexpected. So, what does this hypothetical scenario tell us? The vision of Earth's rotation coming to a sudden halt or slowing down dramatically offers a stark illustration of the intricate web of systems that sustain life on our planet. It underscores how the dance of geological processes, from the spinning of our world to the shifting of tectonic plates, shapes our environment and drives the rhythms of life. It reveals the delicate equilibrium of our climate and ecosystems, teetering on the fine balance of day and night, light and heat. It brings into sharp focus the adaptability and resilience of life in the face of extreme conditions, and highlights human ingenuity in the face of unprecedented challenges. But most importantly, it serves as a potent reminder of our intimate link with the celestial mechanics of our planet. It highlights just how crucial Earth's rotation is to life as we know it.